back in end of 2014, beginning to 2015, I learned about React. And before that, I've been programming some in jQuery, and it wasn't great. I don't know if you ever tried jQuery, but you need to keep all of the application state in your head. And then every time you do something, you have to go undo it in other buttons and so on. So that was very annoying. And then React came and had this programming model where you just start from the top and you go down, and it was just amazing, like a real epiphany. And I just loved it from the start. So, I started using it, and then you add some Redux for state management, and you do some SSR, and you maybe add some GraphQL and some React Select or other things, some style components, some immutable. And after a while, you start to notice, hey, my app is getting kind of big. And then you have to go and manually optimize and take things out or replace them. So it is kind of a drag to just optimize, right? And then all this time, new frameworks came out and they promised things, but they never really were it for me because I really like the programming model of the top-down thinking. And yeah, I don't like templating so much. And the cost benefit wasn't that perfect for me. So then I heard about Qwik, like supposed to be good, right? So I go to the site and I check it out and I go, just yet another framework, and I just close it. No. But then I think, and I go like, what is this resuming thing? And then I open it again and I read them, and then I go through the tutorial and I go like, wait, this could be something. This is pretty good, right? And so I just go through it and I find all these amazing features, like there's signals. You can just put promises in your DOM. Anything can be a server component or a client component, like who cares? And nothing impacts the size of, so your application is just fast. You don't have to worry about it anymore. And so here is something that cost benefit did seem good. You have something that's fast, stays fast, and it's more fun. So it was a big problem though. There were no styled components. So I go there, I make an issue. Where's my styled components? And after a while, I realized, CSS has grown up. It's better now. You just use CSS variables. So then there was this project called Vanilla Extract, which allows you to do stuff. And I just wrote styled components in Vanilla Extract, and I made it a plugin for Qwik. And that's how I got sucked in. So some 300 PRs later, I am a core team member for Qwik, and I hope to take you on a inspection of the internals to see if you can share my enthusiasm. Let's dive right in. Let's just go wild hog, okay? So on the left-hand side, you see what you would write in React maybe, except that there's some signals there, but it looks very, very normal. And on the right-hand side, you see the resulting web page. And as you can tell, there's a main. The main is there. You can see it. And the value is there, 37. Yep, it's correct. Use signal 37. And then onClick dollar changed into on clicks some string. Okay. And then there's this whole array of things. But where did my component go? I had a component right there, main P. Where's the script? There's no script. In fact, this is the script. Like on click, that's the script. And also, this little line here, the 37, when some signal changes, it will call this function and 37 changes. So now let's look at how this magic happens. Okay, so for me, there are 4 pillars that really make it work, and they all pile onto each other. They help each other, they strengthen each other, right? So first of all, we have children decoupling. And I will explain this. So we have children decoupling, we have segmenting the code in pieces, we have fine-grained reactivity, and then just promises everywhere. Okay, now let's look on the left again. Completely normal React or Qwik component. This could be anything, right? So this works in both React and Qwik. On the right-hand side, we need to change it a little bit. We need to add component dollar, and we need to replace children with slot. right? So children is no longer visible for your parent. The parent component has no idea what children are. All it does is render slot and then hope for the best. And for the rest, you can see the child component didn't change. The export default, you can put a component there. You don't have to. It's called, if you don't put component $, we call it an inline component. So it's a lot like React. Okay, why does this matter? On the left, again, we see a DOM tree. Each of those balls is a component. And suppose that the component over here, there's some change, like some prop changes, and it needs to re-render. Now, because it has children, its children also need to re-render. And not only that, you have to provide the data for it to re-render. So you're being punished twice, basically. Extra work for nothing. Over here, we have the slot. So when there's a change, this parent component changes, and that is it. Nothing else has to run, and you don't even need to provide the children data. So if you don't have children or you do have children, it doesn't matter. You don't know what is going on there. It's fine. Then the next pillar, code segmentation. What is it? You have a JavaScript file, and then we have something called the Qwik optimizer. And this is a graphical representation. So beware, it's written in Rust, so it's a bit complex. So this is what it looks like. Yeah. And so it cuts the JavaScript in pieces, just like that. And it gives them some names, and it's done. And it also, internally changes some things. It replaces JSX, that kind of thing. So how do we know where to slice? And this is where we have the dollar, the almighty dollar. And in fact, if you like dollars, Qwik code bases are the place to be because we just have dollars everywhere. So what does it look like? Here we have a more typical Qwik component, and we see component dollar, use task dollar, on click dollar. The optimizer takes this file and cuts it in pieces. The first piece is the application. So this is basically what we call the parent. And as you can see, we have application is component QRL instead of component dollar. And then a function, some import, and some name. But all the rest is gone. And then let me give you the name again. So here we have app component blah. And here we have the same app component blah. This is the contents of this function, a little bit expanded and moved into a separate file. And as you can see, inside it, there's more dollars. So we have use task dollar. It becomes use task QRL with some QRL function in there and some value. And over here, the onClick becomes onClick dollar QRL. Now I want you to notice this sig and toggle, because when you take files and you just move code in a different file, then the signal, which is here in scope, is just gone, right? You cannot access it. So what do? You provide it via the QRL call. So this is what the optimizer does automatically. It says how to get the code, what is it called, and what are the variables that are needed. And here we can see the onClick handler. So this is the contents of here. You can see it returns toggle value, not toggle value. That's the code over here. And it has some boilerplate. So these chunks, we call them QRL segments. And it's internally, it's an object. So QRL is a function. And it just writes down, here's the function you need to call to get the code lazily. Here's what you can call it. And here are all the variables that it uses. And then the segment itself has this use lexical scope function that it gets from the framework. And with that, it can ask for its variables. And all of that is just automatic. You don't have to worry about it. It's just fun to know. All right. Good. Next up, promises, server stuff, just anywhere. You can do everything, right? On the left-hand side again, We have an example. So again, a component, and then here we have something called server dollar, which is coming from Qwik City. I will tell you in a second. And it seems to call something from a server database, right? And here we have just another component, and the get quote that it gets back from server dollar, we just put it in there. Now, what is Qwik City? It's our router. It's very opinionated. It has file-based routing. It has a ton of features. I probably don't have time to go into them. So just accept that it's great. And on the so when the optimizer goes through this code, the client code looks like this. Over here, the server dollar call gets converted into a no operation QRL. So it doesn't provide a function to call because there's nothing to call on the client. We don't want to call the server database on the client. So that is cut out. Instead, it just says, hey, if you want to do something, that's the name, right? And then on the bottom, you can see the get quote. There's nothing special. It's just returning get quote inside the JSX children. And actually, by the way, these JSXQ and JSXC, they're optimizations. They allow saying these properties never change and these properties are variable, so that when doing DOM diffing, we can just skip a whole bunch of properties and just be that, that millisecond faster, right? Okay. Now the server code, it does get something in the code. Oh. So here you can see it's no longer a no operation QRL. It is just a file. What is the file? Here, the server import and just calling it. So it moved the server import into that file. The client code doesn't see the server import, and your build doesn't fail because you're importing process.env, whatever. Okay. Third pillar or fourth, no, third pillar, fine-grained reactivity. So signals. Does anybody know what signals are? Raise of hands. Yeah. Okay. Yeah. So what is a signal? It's a little magic, but like contained magic. So it's an object that has a dot value prop, and when you try to read from it, it's actually a proxy, and it knows when you're reading from it. So the framework will tell it on a side channel, hey, I'm going to run this component now. Like if someone reads from you, it was that component. So signals get read, it writes down, this component is reading from me, this task is reading from me, it's just writing that down. And then when the signal changes, it will go to this list and tell all of them, hey, I changed, you need to redo your thing, right? And that's what happens here. So if we just look at this component, we have use signal hello, toggle use signal false. There's a task, there's some things. And if you have the button here, and when you click it, it sets the value to true. And here we see toggle is toggle.value. So the component is subscribed to the signal. Likewise, we have a task. And if you're running on the client, then it will do a timeout. Well, actually on the server as well. I guess I should have put a little thing in there to prevent it from running on the server. But whenever you toggle, it will change the hello to hi after 500 milliseconds. Now, what is fine-grained reactivity? We don't want to just run components all the time. We want to just do the changes, because what changes is we have the value here is what changes and the value there is what changes. Nothing else in the component changes. So what the optimizer does is it takes the signal, and instead of doing signal.value, it puts it in a little function and it gives the signal without reading it to the framework. So now we see we have fn signal here and here. It gets past the signal without reading it, and now this component is no longer reading the signal. And this happens automatically, right? So now when you change the signal, it's only going to be read at the place that it's actually needed. So here we have this attribute, it actually needs the value. it changes, it will change only the value. It won't rerun any component. It will just go to that one single value and run this function p0.value or true false and change the attributes right there. So this is really, really tiny code. Okay, now that we have everything together, I hope you better understand what's going on here. And the only thing I didn't explain yet is, oh, sorry, is this state, right? So we have a big block of state here. So again, we have an on-click handler here. Some magic in the Qwik framework tells it that you should be running qwikcore.js function run and then 0, and it should do something. And here as well, somehow we are telling the framework that this 37 is related to this function. And the details aren't that important. What is important to know is that here there's a script called Qwik Loader, and it's like it's like 2 kilobytes compressed. It just goes in line with the HTML page, and as soon as the HTML page runs, it sets up handlers for all the events that the Qwik application needs, and then when you do a click, it will store it until the framework is ready to process it. So you will not lose any events, it will just be there. What that means is that you don't need to run any framework. You can just sit and wait, and only when the user does something is when you start to run this function and give it the data. And this is all encapsulated in this state and these strings. Now let's look at how a DOM tree looks. We have the application, we did SSR, we have this DOM tree, and in fact, we notice the only thing that can happen is that someone clicks because that's the only event that we're interested in. And then the only things that can change are like 2 nodes that get a signal. So why should we bother with all the other nodes? They don't cooperate in anything, so we can just ignore them. We just send HTML, and the only thing that we send to the browser are those 3 nodes, and only when you actually use them. So let's look again here. This is done with this quick vnode thing here. So we have our function, our HTML body, and this encodes the location of the one place that needs to know about the state and clicking. And again, this happens automatically behind the scenes. Now, because we only have 3 nodes, we don't need to copy the entire application state. You could have an entire blog post in here, and if it never changes, you don't need to send it. You just have the HTML, you're done, right? And so what we do is we go visit all of these nodes, we check what data can they access, and we send it to the browser so that when it needs it, it can access it. And we can do lots of things like native date, native map, native set, our own objects, QRL segments, JSX output, and we can also do this in the other direction. So you can actually send something to the server from the client, and it's also being encoded, and then the result is also encoded. And the important thing to remember is the only code that we ship is the tiny, tiny cut up pieces that are necessary to make those specific DOM nodes work. Okay, now there's one problem. When you do this, you end up with 1,000 small files, and the browser, when you click on something, it will take 50 milliseconds to get it. And on bad network situations, you have like 300 milliseconds, 500, and it just becomes a problem. So we need to tell the browser, hey, you're probably going to need this and need that and so on. And that is also automatic. So this is actually a technology preview. We used to do service workers, and now we made it go into the application itself, and it uses probabilities. So when you do SSR rendering, it knows these nodes need that code. So we just tell the browser, you're going to need this code, like just start preloading it. If you don't want to, that's fine. But if you want to, please preload this. And then we actually load a piece of the core, but not the entire core. This module is 2 kilobytes, and it's super cacheable. So this module gets imported, then initialized to say, we are running here, you can get the information about all the modules there. And then we're telling it, hey, on the page you will find this, QRL, so segment names. These are all the events that are possible. And then what it does is for each of these names, it knows how likely is it that this is necessary, how interactive is this piece of code. So for example, if you think back to the server dollar, that code isn't very interactive. I mean, it might be, but all it does is it tells the client, hey, go ask the server for this, right? And on the other hand, you have the onClick handler, and it's very interactive. If you click it, you immediately feel that it's missing. So it's much more important to load the click handler first. And then if you have multiple click handlers, they will all say, well, I need the framework, to run. And then each of them will have a certain probability. So for example, let's say at the top of the page, there's like a 40% chance someone clicks something, and then as you go down, it goes down. But each of them is importing the core. So there's a 40% chance that it's 100% needs the core. And there's another 30% chance that it 100% needs the core. So the core percentage goes up, and it keeps track of all the bundles that it knows about. And the ones that are at the top, it starts preloading. So it just tells the browser, download this, download this, download this, download this. And that way, the code that you need is there before you click it. So that is the magic that makes Qwik work. And as you can see, those are the pillars, but there are other things in there. You have the serialization, the preloading, lazy execution. And in fact, there's a whole bunch more things in Qwik, right? So that brings me to the next part of the presentation. I said Qwik Go For 100. Why did I say that? Because of Core Web Vitals. So Google has these Core Web Vitals, and they are very important for any public site that you want to be searchable, because Google will look at it and say, this is a good site, this is a bad site, depending on how good your score is. And let's look at what each of these are. So we have largest contentful paint. That is impacted by data coming in, like images, fonts, your just the framework loading and rendering things. So if that happens late, that becomes a very late number. Then we have the interaction to next paint. When you click something, you want to see something change on the page. And Google keeps track of that all the time. So it's not just the first one. As long as you're using the application, it's like tracking, oh, he pressed the key, oh, 27 milliseconds later it's there. So it's keeping track of that. And it doesn't, if that's bad, then the user starts clicking because nothing happens. And then the content layout shift, that is really up to you, because you made a mistake in your CSS, or you forgot to put dimensions. And what happens is you want to click a button, and suddenly the button moves down, and you click the drop down menu that says delete, and you go like, ah. Then we have some more core web vitals. Non-core web vitals. These are also important. They are good to know, but they are not what Google measures. They're just going into a little score sometimes, but it's not the ones that are actually important. So we have how long it takes to get the first byte of your web page, how long the main thread is blocked running JavaScript, how long it takes to become interactive, like you do something and there's actually stuff happening, how long is that first period of time. And then we have the first contentful paint, that is the same thing as largest, except the first. The largest one is where Google determines now there's something visible that the user would like to see. Now, how does Qwik help with all this? So let's look at it. Let's see what happens. So we have the largest contentful paint. It can be impacted by your CSS being bad. You have big CSS, it's in a file, it doesn't download, it blocks everything. It could be your SSR being incorrect, like it didn't render something, and then you hydrate and your application just decides to put something else. It could be the code being slow, it could be the framework being slow, or the network, or the server, like just all things can impact large. So this is the most important number, I think, right? Then interaction to next paint, that's mostly impacted by the code being slow. So it's not in the browser. That's probably the reason that it doesn't work. That's the most important reason. It could be a slow framework, but that's probably not very likely. Then the uh, content shift, that is entirely your problem, right? So you did it, you did the bad CSS, you used the wrong image size, you can totally fix this, there's no excuse. Then we have our time to interactive, again, related to code. Total blocking time, again, related to code. If you have a React application, it's 1 megabyte. It needs to download the megabyte. It needs to parse the megabyte. It needs to run the megabyte. It needs to hydrate. It's just a lot of things. Now, when you have Qwik, those things change, right? Our SSR became good because the SSR is the page. Like, it's there, it's done. Fast code. There's nothing faster than exactly the code you need, right? If you need less code, then there's no code. And we also support no code because we don't ship it. And then it's a fast framework because, trust me, bro. Then you could even argue that it helps with the CSS part because it will tell you, hey, you put an image tag in there and you didn't put width and size. And it also allows you to import an image as a JSX component. You just put it in there. It will automatically convert it to a number of resolutions, put it in your assets, render it with all the correct tags. So you could say, Qwik is helping out here as well. So the important takeaway here is everything is automatic. You don't need to do anything, and you get good scores by doing nothing. So here's some proof. If you want to see this for yourself, you can just go to the Performance tab in your DevTools, and you can see largest contentful paint, CLS, interaction tag paint. So it keeps track of those. You can just look at them. And you can also record your performance, and it will tell you the various metrics. It will also show you what is downloading and what the page looks like. So this is a very useful thing. In the Performance tab, you just hit this button here, and it starts the page load, and it looks at exactly what's going on. And then here at the bottom, very hard to see, is the navigation succeeded. I don't even know what DCL is, but if you click it, it tells you first contentful paint, page loaded, and then largest contentful paint. And what we can see here is we have an empty page with just the HTML. It's downloading a bunch of fonts. It's downloading images here, these green things, favorite icon, more images. And with Qwik, as soon as it has all the images, it renders the page, largest contentful paint done. It doesn't get faster than that. You have the images, your page is done. And then here you see the army of modules that it starts to preload so that when you click it, it's available. But you have to do this in anonymous mode because extensions like to put stuff in there as well, and then it messes things up. So for our documentation side, these are the numbers. Pretty cool, I would say. Pretty close to 100. And here's a whole bunch of sites. You can go to qwik-showcase, and people just submit their own Qwik site, and then we get the numbers and we show them to you. So pretty fair, I would say. So now it's your turn.